So we're excited to share some of the project updates today with you, and hopefully share the excitement that we have generated down in Chatham County. And before I go on any further, I'd like to introduce Russ Clark, who is the project co-lead from Georgia Tech. He is a research scientist in computer science and engineering. And then Randall Matthews, who is at the Chatham Emergency Management Agency down in Chatham County, and our community partner lead for the project. But before I go any further, I wanted to kind of branch out. Well, first, just to introduce myself in exhaustive detail. My name is Kim Cobb, and I am professor of Earth Atmospheric Sciences. I'm actually a climate scientist by training. And that's what brings my interest to this project on sea level rise and emergency planning and response specifically. And then to note that it falls very much in line with a new program on campus. I wanted to mention the Global Change Program that is just kicked off in March, so we're not even quite a year old. And so this project that we're going to talk about today really represents some of our goals, our highest goals actually, for serving Georgia communities in the area of climate solutions and adaptive responses and management as well. So just to highlight that. And I'm assisted in that effort by somebody who needs no introduction in this room, probably Dr. Wayne Clough, who's honorary chair, an important mentor and spiritual guide for the program. And so this is a consortium of folks that come together under the Smart Communities Challenge, including the Global Change Program. And then we have our own URL now for the project, because it's growing so fast, it's hard to keep track of. And I wanted to spend some time introducing the rest of the project partners here who couldn't make it today, noting that we have City of Savannah as an important community partner as well. And from the mayor's office down through our project partner, Nick Deffley, who is the director of the Office of Resilience down there, including emergency managers and floodplain managers, Tom McDonald and David Donnelly from the City of Savannah. On the Georgia Tech side, we have a very, very deep bench and growing almost every day. So we have a lot of researchers and talent on board. Russ and I are the co-leads here. And I should note, Russ has had a lot of support from GT Savannah that he can talk about in a minute. And David Frost from Civil is on board, kind of thinking about disaster response and infrastructure. Dr. Emanuele Di Lorenzo is from Earth Atmospheric Sciences. He's an ocean scientist and ocean modeler. Lalith Polapetti is a research scientist and data geek and AI specialist with the Global Change Program. Jaima Koval is in seismic, which reflects one of our key efforts involved with outreach to the K through 12 communities in Chatham County in the City of Savannah, so that we can get project data in the hands of students, get sensors in the hands of students, and engage those kids in their own smart community project. We're very excited about that. It's also contributed by Tim Cohn, who's the director of K through 12 outreach at GT Savannah. And so we have these really important folks down on the ground in Savannah helping us think about this, and a huge amount of effort going into building that capacity that will involve infrastructure capacity at GT Savannah in support of this initiative. So I really want to highlight that at the ground here. And then Andrea Rogers, who's part of our communication staff, who's helping tell the stories of the project as we go forward as well. Moving on to the Chatham County Emergency Management Agency, obviously Randall Matthews is here today, and I wanted to allow him to say a couple words about the project from the SEMA perspective and some of the motivation and value added, and why they have committed, frankly, so much resources to enable the project's success.
Thank you, Kim. So this whole project is very personal for us. So we've had a lot of experiences over the last 2 years with hurricanes. Being in coastal Georgia, that is a very large threat. So part of those criteria for hurricanes and hurricane response is what is the status of our bridge infrastructure. So when we need to do bridge inspections, this is a very time-intensive and labor-intensive process. And when you look at hurricanes impacting a regional area, resources are already very limited. So we needed to have quantifiable data of which bridges needed to be inspected before others, which ones may be damaged, and then see how we can better assist the populations that may be affected or isolated because of this disaster. So we needed to have some sort of real-time or near real-time definitive answer of when water actually touched the bottom of the bridge, because that is a criteria for conducting a bridge inspection. So that was the whole thought process behind doing this, but we did have very different experiences between Hurricane Matthew in 2016 and then Hurricane Irma just last year. The storm surge affected communities in a lot different ways, and there's a lot of different storm surge that affected other areas, and we only had one swift water rescue team available at the time, so sending those people into affected areas is really a priority to do. And without knowing exactly how storm surge affected those communities, we were kind of making our best guess, but didn't have a whole lot of solid data to back it up. But now, thankfully, to deploying these sensors, we do. And we've learned some very incredible things so far that Russ Clark will show in his presentation.
I think I have a couple more folks to introduce here. And so on the SEMA side, we are supported through the entire management structure all the way up to the top. We're very grateful for their continued and stalwart support on the ground down there. Without their cooperation, we wouldn't even be able to deploy these sensors on these entities, the bridges that we're talking about. And then last but not least, we have the Creative Coast as a partner as well. This brings in the community aspect, the community engagement aspect. So we hosted our last workshop a couple weeks ago down at the Creative Coast Center and brought together a huge number of stakeholders from the general public to city council members, all the way through the project team and stakeholder teams for around the sensor deployments and education and community outreach, talking about how we could leverage these channels of communication and the community engagement to enhance the project even further. So thinking about the A to Z value chain, as Deborah was talking about, not just the sensor technology, but the ecosystem that these sensors are embedded in, and how we can grow awareness of the things like flood surge and meet some of SEMA's most ambitious goals for the project around protecting property and lives during these events. So that's important. So this is really the guts of our challenge here that we're facing in Chatham County. We have very little real-time tidal information, but we are obviously facing along the entire coast of Georgia, but this is just a map of Chatham County, acute flood risk associated with, of course, now even king tides, but of course during large storm events, storm surges of, in the category 5, up to 28 feet, the entire county is basically underwater in that scenario. So talking about the unknown unknowns, this is actually a known risk, but not one, thankfully, that we have had to live through just yet. But we're in the middle of hurricane season, and this is going to be a perennial threat to the coast of the entire southeast United States going forward. So how do we get ahead of that? How do we manage that risk and plan for not just short-term emergency response, but long-term adaptive responses to this continued and growing threat? This is really the core of the project. Short and long-term risk assessment. And then again, with the communication and building awareness piece, we don't want to leave that behind even at a ground level as we concern ourselves with sensors. How can we engage the community around the sensors and raise awareness of the threat, both short and long-term? And the K through 12 piece is a central part of that strategy as well. And so I'll also end by thanking the partners and turn it over to Russ Clark, who will give you an update about where the sensors are and some of his personal motivation for the project.
All right, thank you. Good morning, everyone, and thank you for joining us today. We have a whole bunch of stories to tell already and a whole bunch of things we've already learned. We'll keep this brief, but we'll be around the rest of the day to talk more and find ways we can work together. This part of the project, the we need to get more sensors out there piece, is motivated by the recent history. We've had 2 hurricanes make landfall on or near that have affected, basically resulted in evacuations east of I-95 and the coast of Georgia. And this is the one tide gauge that is officially visible for all of us, the community, to see what's going on. It's a picture of it that NOAA operates out at Fort Pulaski in the Savannah River. And this is the official tide record of what happened during these 2 hurricane events. And what's interesting is basically that from the official gauge, that Irma, the second event, is actually a couple of its peaks at a couple inches lower of absolute water level. And so officially, and if you look at the national news report, Irma was a less serious event for the coast of Georgia. But anyone who's actually been to the coast of Georgia and experienced what happened knows that that was not true at all. And in fact, many places received 2 to 3 feet more water during the Irma event based on where they were on the coast and which direction the wind happened to be blowing for them at the time of the event. So we know that there is real data actually to back up this experience and these observations. Fortunately, the USGS, US Geological Survey, has a project where they go out before an event, before a storm event, and deploy a bunch of sensors. And then they come pick those back up and make the data available. And we see, in fact, that for Matthew, at this particular point, we had a peak stage of 6.6 feet. And for Irma, we had a peak stage of 8.9 feet. Again, 3 feet, almost 3 feet more water up in the houses, up in the creeks, up in the businesses that were affected by these storms. So USGS, this project has been a big inspiration for us. We were very fortunate that we've had some initial involvement and interest from them. We had, I guess, 3 members of the USGS group join our workshop in Savannah just 2 weeks ago. And we're looking forward to basically working with them to improve what we're doing. It's not just hurricanes. We have stormwater issues all the time. We have pop-up thunderstorms, and we have these supermoon or king tide events that actually result in closing the causeway to Tybee Island multiple times a year. And it turns out we had one just a few weeks ago. So we said, hey, and so this is a great, nothing like a planned flood, right? It was forecast months in advance. The planet, the sun and the moon are going to be lined up perfectly. We're going to have flooding this day. So what does an engineer do? They say, that's an opportunity for science, right? We're going to go out and we're going to take some measurements and we're going to get some things in the field and see what we can do. So we set out to do that, and we said we can deploy some of this new Internet of Things sensor technology. We're using I won't do the full tutorial here, but we are using a technology for this part of the project called LoRaWAN, which basically gives us the ability to do the actual sensor deployment for every bridge at a cost of around $250 versus tens of thousands of dollars for that NOAA gauge. Architecturally, what we have to do is deploy with our sensors a number of gateways or base stations. We're planning to deploy, we should be able to cover the entire county with about 10 to 12 units at a relatively modest cost. And this whole architecture, just one thing I'll highlight is that it uses security from the beginning. It uses encryption and protects the traffic so that we can actually have a reasonably strong story about privacy and data control with all of the applications. So what did we do? We deployed some gateways across the county to get us started. We did a bunch of testing during the tide event, the king tide event, where we drove around actually figuring out where the coverage worked and how things were going. Here's a map where we actually show some of the coverage and some of the connectivity had. So every place you see a dot light up basically is a potential place that we could deploy a sensor of some kind. Important thing about this project is that the water level part of the project as the motivator, as the application that Randall brings to us is just the beginning. The technology actually lets us deploy, whatever sensor you might want to with the same infrastructure. And then we deployed 3 actual bridge sensors at these 3 locations around the county and basically set out to figure out, okay, what can we learn from this process? An important thing, we learned a lot, right? Mostly that we should bring a cooler full of bottled water. That was a thing. It was hot. But we also learned some realities of different bridge structures, things we have to be prepared for as we do the installation. This picture that's kind of dark that doesn't show up, a key aspect of every installation, and this is basically something we rehearsed as part of this trial, was we need an accurate survey done of the bridge, of the actual sensor installation, so that we know, this sensor is mounted at this particular height. What we're measuring is the distance from that to the water level. When we have 100 of these deployed and we're pulling all that data back in over time, what we need to know is, okay, what does that number mean? What is it relative to? And so the survey is very important so that we have an accurate indication of how is this relative to some reference, say, regular, normal sea level, so that we can know what we're really looking at. And so basically rehearsing that installation process and getting the script down so that it's faster and easier to do, but also making sure that we have the data and that all of the science team and all of the engineering team and the county and city folks that we're providing them what they need, right, is a big part of this, why this was a dress rehearsal, right, and not the final thing, because we're learning from that and figuring out what we need to do ultimately. We got lots of really good data from this weekend of testing. We can tell you much more about that later, but the punchline key thing is on, I guess it was Friday night, the 14th or something of August, we had the official king tide height at 8:06 p.m. at Fort Pulaski, but on this bridge that we were, one of the bridges we're testing on, which is, and you can see it in this creek way up in the marsh on the backside of Tybee Island. There the high tide was at 8:14, the peak. And then way back here up on Wilmington Island, the peak didn't come until 9 p.m. And if you've been there, you know they have announced the official high tide at Tybee Pier, but what happens in your neighborhood varies widely, and you don't actually know for sure until you see it. And then this is basically what we want to be able to do for all of the gauges and all of the creeks and all of the neighborhoods ultimately and all of the communities is this tells us not just what time it peaked, but what was the relative height. Because we know from our hurricane experiences that location matters in terms of what the actual ultimate height is. And just because we saw something different between Irma and Matthew, the next storm, the wind is going to be blowing slightly differently, the timing is going to come at a different time, different areas are going to be affected, and we need more data, we need richer data to help with the forecast models and help everybody to understand what these impacts are. So we got some good data. We're working on basically plans for next deployments, identifying sort of our 20 priority locations for this first phase this year. Start the deployment in the next 8 to 10 weeks. For gateways, finding locations, the county and the city have been very supportive in helping us figure out how do we cover the county, what kind of facilities can we use, where can we get access to a high location, where can we get power, where can we get internet access, lots of logistics things to work out. But we're making good progress and sort of plan. That's kind of how this will play out over the next 6 to 10 months. But most importantly, then engaging the community on what the priorities should be, what the educational goals are going to be, what the opportunities to basically do more than just the sea level, but what other pieces of information. We've already had good requests for things like water quality, and temperature and weather-related things, getting community involvement, what's going on, localized flooding on my street, not just from high tides. And so from the, we're off to a good start, but there's still a whole lot of work to do and a whole lot of engagement to happen that is already happening and that will continue to happen. So thank you all very much.